Good afternoon. I'm Simon Daniel, founder of Moixa. It's quite difficult presenting at this meeting because there's so many companies keep overlapping. So if you imagine taking all the companies you've heard today and put them in a blender, there's a very famous thing in America called will it blend, and blend them all together, the output of that is concentrated Moixa. So we're interested in managing just one thing, all the batteries in the world. We're starting from managing home batteries with a leader in the UK and using that inside location management to manage EV batteries and a wider amount of batteries in the Internet of Things. 50 billion devices, most of them have batteries in. What we do is we physically make smart batteries and we put our software onto third parties to make their batteries smarter. We make a platform which aggregates all these batteries for groups so they can be managed and deliver services for utilities, and then we operate batteries in large fleets to deliver grid services. And the result of this is enabling increased yield in solar, it's enabling storage as infrastructure, and it's enabling energy as service. And in the UK, these are large target markets for assets. It's a very interesting market, but you need batteries to manage time in the day and to manage term relationships with clients. And last year, since Ecosummit, we raised 7.5 million. A lot of that was from Japan, from Tepco and Itochu. And what's quite interesting is the UK is an energy island. It's physically and politically disconnected somewhat from Europe and has to manage by itself its energy fluctuation. In Germany, you've got lots of interconnects. The UK has less than 10% interconnects. So what's interesting about the UK is we have a very advanced, flexible marketplace to do these new business models. It's one of the reasons Japan quite likes the UK. It's very similar. There's not a great rush to put interconnects to North Korea yet. And it's a very good learning environment for some of these new business models. We make smart batteries. So this is our TV ad we put out on Sky recently. What's different about Moixa is we tend to make small mass market batteries. We want batteries in every home, not just the 1% elite customers. So these are small, modular, 1-hour install batteries, very cheap cost to the wall installed. And then our platform helps manage these batteries across a range of different beneficiaries, from behind the meter to at the meter value for the utility, to local to meter value to displace capital and manage constraints, and front of meter to aggregate for grid services. And we manage third-party batteries. We have thousands of batteries under management out in Japan through Itochu and EV batteries. And we're using our insight in making our own battery to manage third-party batteries and deliver valued services for them. What we do is help households and utilities do more than just take smart data, do something with the data to deliver smart flexibility. Data gives you price, batteries give you flexibility. And managing that well delivers new business models, helping utilities manage time, helping networks manage location, helping grids manage the system. We support this with various patents. This is a patent we filed 10 years ago on the whole smart interconnected home. And we use IP to basically work with standards. It's very difficult having batteries in people's homes when software is deleted every 6 months. We're looking about how we manage millions of batteries over decades, and this software has to outlive companies which are out there. So standards are very important to us. And also working with real clients. We work with utilities, with battery companies, with DNOs, with National Grid, with EV companies, delivering services on battery, delivering group management services for the utilities to get more value out of the day. And lots of sort of multi-asset platforms to really group batteries together to deliver group dispatch. Here's an example of a project we're doing, a VPP on the Isle of Scilly. It's a £10.8 million project. We're managing the EVs and the battery flexibility, doing a triangulation against heat battery, and managing the whole island. This island gets disconnected from the mainland from time to time, which is quite helpful. And it teaches us how we manage the UK to deal with the swings of solar, the swings of grid. And we're interested in what happens when you increase the leverage on this by having more wind and solar. In Germany, you can dump power on Austria. You can use France as a nuclear battery. UK can't do that. And what we learn by managing a smart island informs how we manage new grids, smart cities. Chicago is a bit like a smart island because a lot of the power is local. And we get a lot of data and experience in doing that in the UK. And we're interested in how batteries grow over time. Obviously, there's a lot of batteries in EVs today. There's several gigawatt hours in Internet of Things. The UK battery fleet will be about a terawatt hour. And with Gerald's data earlier, there's hundreds of terawatt hours of batteries need to be managed daily. These are big challenges for the grid, particularly on a location level. How do you accommodate a fast charge larger, which is equivalent to 44 homes on average. We learned by putting in small batteries on average need to flex the average profile for an average home. If you put too much metal in the home, it's inefficient. You don't need to manage the rare events in the home. The grid is perfectly good for that. But managing EV demand is very, very interesting because it's locationally constrained. And so we're getting a lot of data and experience in doing that. And the last presentation on e-bikes is interesting. There are 50 gigawatt hours of batteries in the e-bike fleet of China. And batteries are growing. The Internet of Things is 50 billion things, most of which are fast-moving goods like phones and a lot of slow-moving goods like appliances, cars, solar panels, batteries. You have to be very, very good at managing these things over term. And we're very interested in some of the new technologies which help ensure persistency. We call it the fax machine problem. How do I manage millions of fax machines today? That's what VPPs are about. That's what the future energy system is about. And we're very keen to be part of that journey. Thank you.